Right, hi guys, my name is Toby. I'm going to talk to you today about our paper, Reliability and Sensitivity of Neuromuscular and Perceptual Fatigue Measures in Collegiate Men's Basketball. First of all, I'd like to thank Rob for inviting me to share our research on this platform, and secondly, to my co-authors Tanya, Ben, Josh, Greg and Chris for all their work contributing to this paper. So the purpose of this investigation was to establish trial-to-trial and intraday reliability and sensitivity of several counter-movement jump variables in a perceptual wellness questionnaire. This was with the aim to assist practitioners draw conclusions regarding changes in performance that may identify athlete fatigue. So Table 1 provides a brief description of each counter-movement jump variable that was used for analysis in this paper. We have a number of typical counter-movement jump variables that are often reported in the literature relating to the concentric phase of the jump. We also have a few alternative counter-movement jump variables that are related to the loading strategy or eccentric phase of the counter-movement jump. Figure 1 displays our wellness questionnaire that we used in the study. Athletes completed this prior to performing their counter-movement jumps. As you can see, we anchored 4 questions regarding their sleep quality, their fatigue, their muscle soreness and mood on a 5-point Likert scale. And this was designed based on previous research. Onto our results, we used the coefficient of variation cutoff of 8% for a variable to be considered reliable, which essentially refers to the typical error of a variable expressed as a percentage of the mean. Our smallest worthwhile change was used to determine the sensitivity of a variable to detect small meaningful changes in performance, and as we know, is calculated as 0.2 multiplied by the between subject standard deviation. You can see our coefficient of variation for our trial-to-trial condition ranged from 0.6 through to 8.3%, with 14 of the 15 variables demonstrating acceptable reliability. This essentially means that these movements or these measures remain stable between trials 1, trial 2 and trial 3 in a single day. Table 3 shows our intraday reliability results, which show 10 out of our 15 counter-movement jump variables expressing acceptable reliability with coefficient of variations less than 8%. However, none of these were able to detect the smallest meaningful change. You can see mean force and relative mean force express the highest reliability, which is likely due to the direct measurement of force through the force plate. Peak and relative mean force also demonstrate high reliability, however it appears mean force is more reliable. Jump height demonstrates low intraday reliability, despite the instruction for athletes to jump as high as possible. I think this further adds to our discussion on whether jump height alone should be used as a fatigue monitoring tool, as it is a gross performance measure that's influenced by a number of factors such as body position at landing and takeoff. Out of the variables relating to the eccentric phase or the loading phase of the counter movement jump, force at zero velocity showed good reliability and is worthy of a fatigue monitoring tool in collegiate basketball. Each of the other counter movement jump variables relating to the eccentric phase demonstrated moderate or low reliability. Lastly, a wellness questionnaire also produced acceptable intraday reliability. However, it was unable to detect small, meaningful changes. Okay, so practical applications of this paper. We recommend that before a measure is used to assess an athlete's fatigue or impact of training and competition, that its reliability should first be established, as each variable is population specific. Our paper demonstrates that a number of counter-movement jump variables and the customized wellness questionnaire show acceptable trial-to-trial and intraday reliability, particularly those counter-movement jump variables that are directly measured through the force plate. As we saw in our intraday condition, our variables weren't able to detect the smallest worthwhile change. In this instance, we recommend practitioners to use the coefficient of variation to determine biological changes in performance. For a small population such as basketball, it may be possible to determine the coefficient of variation of counter-movement jump measures for each individual to be used as a threshold to identify change in performance.